Yeah. So we will start in 5 minutes. Actually, we are waiting for other participants to join. So let's wait.
Okay. Good evening to all. We are starting the webinar now. Good evening, I'm Ritik and on behalf of ISIEINDIA, India, I do hereby welcome our today's distinguished speaker, students, academicians and professionals attending the webinar on this certification of automobiles, India and global. As the world is rapidly advancing towards mobility, there is a need to create sustainable development of skills for students, academicians and industry professionals to match the industry demand and fulfill their requirements. We know that there are several parameters to consider while learning about the automobile. One of them is certification of the vehicles, learning of the Indian and global government authorities, regulations and standards for automobile certification, compliance of product as per the regulations and a part of various regulatory panels. Also, learn about the certifications for the automobiles like quality, safety and protection of the environment are the major parameters to know and learn. Today, in this webinar, we have Mr. Sahil Bangia as our speaker. Mr. Sahil Bangia is a Special Project Manager at Vehicle Certification Agency and he is an automotive engineer with 9 years of experience in techno-managerial roles related to automotive policy development, advocacy and homologation. He has a vast expertise in government and private sector with specific contributions in setting up Indian policies for real-life emissions. Currently, he is deployed by BCA in product management team of BMW India and working as a special project manager at BMW headquarters and responsible for Indian certification for BMW Mini and Motorrad. He believes in industry academia collaboration, has been a technical judge and a coordinator for electrical mobility events. I welcome you, sir, and now would like to request you to take over further session. Thank you.
Thank you, Ritik, and thank you ISI India for giving me this opportunity to present this webinar on certification of automobiles. So, good evening everyone. I'll just share my screen. Just let me know if it is visible.
Yes, sir, it's visible.
Okay. So today in this topic we'll cover following things. First of all, we'll see what are the automotive regulations, then what is the need for certification, and then we'll cover the list of tests required in the complete certification of automobile. So today we will mainly cover the passenger car segment only. Then for the few of the tests, for example, like mass emission tests and particularly electric vehicle certification, will go in details. And then thereafter we'll go towards the global homologation. So now to the first topic, what are automotive regulations? So it's just basics for everyone to understand that automotive regulations are the laws or the requirements of every country that the automobiles must satisfy in order to be approved for sale or use in a particular country or region. So before launching a vehicle in India or any other country, there are certain set of regulations that a manufacturer should follow, and for those only those automobile regulations have been written. And these regulations cover the aspects such as lighting control, crash worthiness, environment protection and theft protection. Now, what is the need for this testing and certification? So, these are the primarily 6 main parameters that why a full testing and certification is needed for every vehicle. Now, first is due to the social demand. So, we have seen recently that most of the cities in India come under the top pollution cities of the world. So, this is a social demand from many NGOs and the other bodies that strict emission norms should be coming to India. So that is why India leapfrogged from BS4 to directly BS6 without coming to BS5. So the social demand is number one parameter that the certification is needed. Then there are some minimum safety requirements. Recently, you must have seen various cases of fire in EVs, mainly two-wheelers. So to avoid such cases and to make a minimum safety mark, these tests are required. Then there are performance requirement to measure the maybe the maximum speed, the brakes, and the engine power for all those parameters which a manufacturer declare on their website during the launch. So for that, a performance requirement test is required. Then obviously comes the technological advancement. We have seen now electric vehicles coming up and the connected drive coming up. Now with the connected drive, there will be stricter norms for the cyber security. So for all these new things, these regulations have to be formed, and that is what we cover under this technological advancement parameter. Then comes the area of harmonization. So as we know that the laws and regulations are different for different countries. So here also we see that India follows its own specific set of requirements because the environmental conditions, the traffic conditions are very different in India. But if a manufacturer wants to export their vehicle, then they have to follow some other country's set of requirements. Now to avoid all this, the United Nations has developed UNEC Commission that is working on harmonization of the regulations. So for that they are building one global regulation for every parameter if manufacturer meets, and they can certify their vehicles in other countries also. So that is one other parameter that we'll be covering. And then of course we have the conformity of production. So a basic definition of conformity of production, or COP, will be that once a vehicle is launched and it is in the production line now every year also the government needs to test the quality of that product. So they will go to the plant, select 3 or 4 vehicles and then test on the emission parameters. So that is the conformity of production, or we can say COP. And obviously now since the EVs are gaining popularity in the marketplace, so it is very imperative for manufacturers to ensure safety of the public, and a robust testing and certification can help to meet such requirements. So you have seen these recent news articles related to fire in EVs, and that is why testing and certification is very much required in today's scenario. Now this slide covers what are the, when a policy or a regulation is made, what are the basic things that a government official or the entire committee has to take care of. One is obviously the energy security. So now we are having more policies and regulations for the electric vehicles because India wants to get the energy independence and from EVs, and obviously right now we are generating electricity from the fossil fuels, but in the coming future there is a huge scope for the green hydrogen and other renewable energy sources role. Then obviously the infrastructure development, low cost of mobility, reducing air pollution, then employment generation, Make in India campaign, and obviously the reduction on oil import bills. So this is the basic regulatory mechanism in India. So if you see, this is particularly for the automobile sector. These ministries are involved mainly in the automotive regulations, which is Ministry of Road Transport and Highways, and Ministry of Heavy Industries and Public Enterprises, Ministry of Environment and Forest, Consumer Affairs, Director General of Foreign Trade, and other state ministries. Now these ministries, they have formed certain committees. For example, this CMVR, which is the Central Motor Vehicle Rule, which is the Bible of the automotive regulations in India. So this takes care of the entire safety and entire laws and regulations pertaining to motor vehicle rules. Then a separate committee to develop those standards is the Automotive Industry Standards Committee, AISCE. And then, due to the air pollution concerns, a separate committee for the emissions was formed, which was Standing Committee on Emission Legislation. And then there is obviously the BIS, Bureau of Indian Standards, and that is not only for automotives but for the other products in the country as well. And once this standardization process is completed, then the vehicles are tested or homologated in these type approval agencies. So, for example, ARI Automotive Research Institute of India, which is located in Pune, then ICAT International Center for Automotive Technology, it is located in Manesar, Gurgaon, and there are other test agencies, for example, GARC in Chennai, NATRAX. So, all those are responsible to conduct the safety testing and give the final type approval or homologation certificate to the manufacturer. So briefly, just to describe how is the automobile certification process in India. So for example, once the vehicle development on the side of manufacturer is completed, then he has to prepare the entire technical specs, which can be a maximum up to 500 or 600 page documents, including all the drawings and all the specifications of the engine, or in EVs related to battery controller, all those things. Then an application has to be generated with the type approval authority. Then if there is a new model launch, or whether there are some changes in the existing model, based on that the worst case is defined. Now what is worst case? All the tests need not to be repeated for every new model launch. Certain tests can be skipped if they have been performed previously on a older version model, and the only tests that have to be covered should be the test pertaining to the new changes. So for that, worst case criteria definition and the list of tests has to be submitted to the type approval authority. Then after this decision that how many tests have to be carried out, then obviously the next step is the conducting those actual type approval tests with the agency, and then submitting the stamp specs, and finally, if everything is within limit, receiving the type approval certificate. Now, we have various categories of vehicles in India. For example, the passenger cars, those are called M category of vehicles. Similarly, the two-wheelers, those are called L category of vehicles. And the commercial vehicles, trucks, all those are N category of vehicles. So now here in today's presentation, we will be covering only the M categories of vehicles, which are the passenger cars. Now for passenger cars, tests can be divided into following major categories. One is the environment tests, then there are dynamic and performance tests, then there are electrical related tests, safety tests, component tests, and tests specific to the EVs. So in today's webinar, we'll be taking a brief look at all these categories, what are some major tests conducted in these categories, and we'll be discussing in details two types of tests, which are the environment tests and the test specific to the EVs. So now just some major tests that are conducted in dynamic and performance tests. So first is the goes down test. Now what is a goes down test? So actually the goes down test is required to derive the frictional parameters in a vehicle. So what happens is that a vehicle is accelerated to a certain speed, and then it is the throttle is just lifted up, and it is automatically comes to a stop, and the time is noted till it comes to a stop. Now there are three major friction parameters that are derived from this test, mainly the air friction, the rolling resistance, and the wind resistance. Then there is a pass-by noise test. So there are certain criteria for the maximum noise that a vehicle can generate, and for that pass-by noise test is conducted. Then obviously very important test for the brakes, like ABS, etc. Credibility test is conducted in which the vehicle is driven on the slope and it is seen up to how much maximum slope it can go. Then there is speedometer calibration test, which tests the performance of a speedometer with some master equipment, whether it is complying with that standard equipment or not. Then there is a hood latch test, which is tested, which is more of a safety requirement, but it is comes under dynamic test because it is conducted on the track. Then there are certain electrical and electronic tests, for example, the lighting installation test, which is used to see the lighting performance of a car, and then windscreen wiping system, whether it is functioning or not. Similarly, DMS defrost. Then very important test of the electromagnetic induction and electromagnetic compatibility. So we know there are many electronic components in the car today. The ECU is the major part, and there are many controllers, many semiconductors, which form the entire structure of a car. Now every electronic component or a system has the electromagnetic radiation which can interfere with each other, or the from the outside radiation. So to test that electromagnetic compatibility, this test is conducted. Then specific for India, there is the seat belt reminder and speed alert warning, which is conducted. Then there are many safety tests. For example, there is child restraint system, crash tests. Crash tests include the lateral collision and also the front collision. Then there are tests that that are to define the performance of the anchorage of the seats and the seat belts. Then another important test is the pedestrian protection. So not only for the driver or the passengers, but also for the pedestrian. This test is conducted to evaluate the level of injuries that a pedestrian will pertain in case of a crash. So now coming on the environment test. So the environment test, which is basically the mass emission test, this is covered under the automotive industry standard AIS 137, and it is not a very simple test as it may sound. There are many types of those tests that have to be completed in the to comply with this environmental standard. So there is type 1, which is the measurement of pollutants from vehicle exhaust. Then there is type 2, which is the idling emission. Then there is type 3 test, crankcase emission. Type 4 test, evaporative emissions. And now very recently there is this clause of the real drive emissions also. These are the major tests of the environment test, but these are not all the tests. So these are the basic which have to be covered. There are new requirements related to the OBD and related to the IUPR and the ISE. ISE is the recent formed norm which tests the customer vehicles also. So this is just the broad division of those environmental tests that we'll be covering here. So now what is a type 1 test? Type 1 test, as we discussed, is to measure the pollutants coming from the exhaust of the vehicle. Now how this test is conducted, as you can see the vehicle. So this is the vehicle that is mounted in a lab in a perfect environment condition. The environment conditions are 20 degrees to 30 degrees Celsius. Then these are the rollers, or which we call as the chassis dynamometer, on which the car is driven. So on the basis if it is a front wheel driven or rear wheel driven or all wheel driven, the dynamometers are respectively locked. So there is a cycle that needs to be run for a mass emission test. So in India we follow the modified Indian driving cycle, which is this kind of cycle, and this is one real scenario photograph from the lab. So what a driver needs to do now is to follow this speed and time cycle. So as you can see, in India we covered till 90 km/h only. So this is very India specific, because in India the speed limits are less. Now this is a full 20-minute cycle, and during this entire 20 minutes, the vehicle exhaust, flows through this exhaust pipe, exhaust flow meter. There are many equipments like CVS and emission analyzer. So basic parameter is that emission analyzer will be calculating the ppm level of all the pollutants that are defined in the standard, and they should be within the limit. Now this table defines what are the limits of various pollutants and which main pollutants are covered during the mass emission test. So the major pollutants that are covered are carbon monoxide, which is CO, then total hydrocarbons, THC, then NMHC, non-methane hydrocarbons. Then we have very important NOx, particulate matter, and particulate number. So as you can see, we are covering today M category. So for M category of vehicles, so PI is the positive ignition engines, which are mainly the gasoline engines, and CI is the combustion ignition, which are mainly the diesel vehicles. So in PI, the CO is 1000 milligram per kilometer. These are the new limits as per the BS6 standard. Now after type 1, as soon as the type 1 is completed, there is a type 2 test, which is very similar to the test that is done on a roadside PUC test that we conduct every year or every 6 months for our personal vehicles. In this, there is no cycle. The vehicle is just at the idle stage, and the CO, HC, CO2 or O2 are measured. Third type of test, which is called the type 3 test, is the crankcase ventilation. So here what happens is that now not only the emissions from the exhaust of the vehicles, but there should not be any leakage or any air circulation through the exhaust on the crankcase also. So it is tested in 3 conditions: one at the idling, and second 50 km per hour in third gear, third also 50 plus minus 2 in third gear. Now what is the method? The pressure in the crankcase is measured using inclined tube manometer, and the vehicle is satisfactory. And the pressure measured in the crankcase does not exceed the atmospheric pressure. That means there is no gas that is coming out of the crankcase. Then another important test, which is the type 4 test. This is particularly for the gasoline vehicles only. What happens in a gasoline vehicles is that gasoline has a property to evaporate very fast. Now when a vehicle is driven and is in hot condition, to ensure that there is very less evaporative emissions, the manufacturers use a device known as canister, which traps the evapes. So to ensure that whether it is within limit or not, the authorities will conduct an evaporative emission test for the gasoline vehicles. In this test, as you can see from the photograph, this is a chamber, a completely sealed chamber known as shed, which is the sealed housing for evaporative determination. Now in this chamber the vehicle is kept and the chamber is sealed, and then there are two different cycles. First cycle that covers the scenario when you have run the vehicle and now you have stopped and parked outside your house and it is in hot condition. Then what is the evaporatives from your car? And second scenario, when your car is parked in the outside, when there is sun and then there are varying temperature conditions, then what are the evaporative emissions? So these two scenarios are covered in a type 4 test. So this is a basic flow chart. I'll not go into all the technicalities, just the basic what is the procedure to conduct evaporative emission test. So in start of the test, the fuel is drained and refilled, and then on the chassis dyno there is a particular cycle that has to be covered, similar to the cycle that we have seen for the type 1 test. And then after these cycles are completed, vehicle is placed in the shed for the hot stop test. So hot stop test is that test which is covering the scenario when the vehicle is driven and parked in the hot condition. Then it is soaked for 6 to 36 hours. Soaking basically means the vehicle is kept in a controlled temperature and pressure conditions. And after that there is a test which is known as diurnal test, which simulates the scenario where there are varying temperature and pressure conditions. And then the test is ended. So in this entire flow chart, the total hydrocarbons that are measured in the evaporative test should not be more than 2 gram per test. So this is the limit of this test. Then now very recently in India we have now real drive emissions test. Now you see what is, like, we are already conducting the mass emission test on the chassis dyno. Question will be why we need this real drive emission test. So there were some global influences which found that there are differences in the results of the test lab versus the actual road results. You all must have seen the Volkswagen case. That study was conducted in the US. There was the issue of the test cycle recognition, or what we call as defeat devices that might be installed in the vehicle. And it was found, as you can see from this picture. So this small cloud is the lab emission test from the lab emission point, which you can see 0.5, and these are NOx results. But the actual was 1. Similarly, for Euro 4, we see this is 0.5, which is the lab result, and in the actual condition, it was 0.8. So there was a huge difference between the lab results and the actual results outside, and that is why these real drive emission tests came into formation. Now, why there is such a huge difference is because the lab test that we discussed earlier is conducted in a very specified set of temperature conditions, which is 20 degrees to 30 degrees Celsius, and also humidity and pressures are controlled in that. Whereas in this real drive emissions, there is no control of temperature. You can go from -7 to plus 45 degrees Celsius, and then there are rain conditions, windy conditions. So due to all those parameters play a very important role in the emissions, particularly the NOx emissions, and hence there is a huge variation from the lab results. Now, because this study was done, so the authorities had to ensure that the real drive emissions also comply when taken a reference to the lab emissions. So this was first formed in Europe. Now the Indian RD had to be different, because when we are talking about the real driving emissions, we have to drive on the road. Now the Europeans when they formed the regulation, they defined the driving speed parameters up to 145 km per hour, which is not possible in India. So there were studies conducted in 3 major automotive regions: Delhi, Pune, and Chennai, and there was many years of research data that was conducted, and finally the RD for India was formed. So again, why RD? Because there is a traffic due to which the randomness occurs. In the lab, we are conducting the test on a very specific cycle, but when we go outside on the road, the speeds vary as per the traffic conditions. Then also the temperature, there can be variations day to day or within the day itself. Then if there are some hilly areas, there can be variation in the pressure conditions also. So now, what are the impact on emissions? So obviously, the drive cycles have a huge impact on emissions. How whether MIDC, as we discussed, is being driven, or the real world emissions is driven. So that affects the emission parameters. Then every one of us has a different driving style. it can be aggressive, it can be moderate. So depending on that, you must have seen in cars these days there is economic mode, eco mode, comfort mode, or the sports mode. So based on that also, the emissions are affected. Then there is impact of altitude, which we discussed, and obviously the impact of wind and traffic turbulences. So why Indian RD is different, because now speeds, there are different speed for conducting the RD test. The dynamics accelerations are very different. Reference cycle, which is the modified Indian driving cycle, which I showed in the previous slide, is followed, and the boundary conditions of the temperatures are very different. Now this is a flow chart of how a RDE test is conducted. So there is a device known as PEMS, which is the Portable Emission Measurement System. So now the entire lab, which I showed in the previous slide, is shrinked to this piece of box, and it is installed behind the car, and it is driven on the road. It is a full 90 minutes to 120 minutes of tests, and after that test, the results are taken from this device, and the report is generated and evaluated. So these are the boundary conditions for India. Temperature should be 10 to 40 degrees Celsius, altitude up to 700 meters above the sea level. Then there are extended conditions where altitude can vary from 700 to 1300 meters. Speed requirement, as you can see, the Europeans can go above 90 kmph up to 145, but in India we have motorway to 65 kmph. Now coming to the electrical vehicle certification. So what was the initial background for the EV certification that we'll be discussing here? So as discussed earlier, there is a body CMVR, technical committee, that brought the BOVs, which are battery operated vehicles, under the purview of CMVR. Then a subcommittee was constituted for defining type approval procedure for electric vehicles in November 1999, back then, comprising members from different automotive and type approval authorities and bodies. And then these AIA standards were published. Now for electric vehicles also, there are different categories of EVs, and the testing and certification requirement vary as per these different categories. So there can be this off-road vehicles within the campus for which even the certification is not at all required, which run within the universities or resorts. Then there are two-wheelers which are less than 250 watts. Then we have also seen e-rickshaws and e-carts. So those, from here the certification is now required, but the requirements are very less for e-rickshaws. Then obviously the four-wheeler passenger cars, which comes under the M and N category. Electric two-wheeler, which are coming under L category. Then there are e-autos that are coming up now under the L5 category. And then obviously the buses, which come under the heavy vehicles category. Now this defines the regulation framework for EVs. So as I told, these are the various standards, AIS 038, very detailed standards that go deep into all the technicalities and the limits that have to be followed for every electric vehicle manufacturer. Then now there are these standards also wherein your gasoline or diesel vehicle can be retrofitted to the electrical vehicle. So for that there is separate standards that have been formed, AIS 123. So these are the steps for basic categories when we talk about electrical vehicle testing. There is verification for the functionality, construction, telltales, lighting. Then there is safety of the vehicle, comes electric shock, water effects, battery safety. Then obviously the performance, what is the range that your electric vehicle is giving, what is the energy consumption, power, credibility, all those parameters. And finally the CMVR approval. So as discussed, testing for different categories of EVs is very different. You can see here below 250 watts, you can get an exemption certificate in certain cases, and in certain other cases you might need to conduct 1 or 2 tests. So these are the basic list of tests that are conducted for the certification of electric vehicle, which are requirements for construction and function safety, then measurement of electrical energy consumption, measurement of range, measurement of net power, and to the right hand side are their reference European standards. Yeah, sorry. So now when we talk about the electrical energy consumption, so basically it is a determination of electrical energy that is required for mains for charging per kilometer of your travel for the EV. So this result is generated in watt-hour per kilometer. Then ISIEINDIA 040, which talks about the measurement of range. Again, this test is done on the chassis dynamometer. So how this test is conducted, the battery is charged to the full capacity, and then the vehicle is driven on the modified Indian driving cycle, which we discussed earlier. So the entire distance covered till the battery is completely exhausted is recorded, and that becomes the range of the vehicle. So again, in future we will find, when we'll start using EVs, we'll find that this range will be very different from what actual range you are getting in your EVs on the road. Again, due to because in the lab we have controlled environment conditions, and a particular cycle has to be followed. But when in real scenario, when we are driving the vehicle, there are many different modes of driving and different conditions which might affect your entire range. So right now for the range there is no real drive range test, only it is conducted in the lab. And then every manufacturer has to declare the power of their motor, and that is conducted using this ARE041 measurement of net power, the motor dynamometer. So this again just describes the types of tests that we are doing for the functional and construction safety. Now we talked about the EVs as a whole, but now very important test in the certification of electric vehicle, which comprise of more than 40 to 50% of its cost also, is the battery, the high voltage battery, and hence there is a separate entire regulation that has been made for vehicle battery approval, and that has to be tested separately to the vehicle. So what are the major tests that are covered under the vehicle battery approval? These are the vibration test, thermal shock and cycling, mechanical shock, mechanical integrity, fire resistance, external short circuit, and various functional tests like overcharge, over discharge. So now what is a vibration test? Now during its entire life cycle, your high voltage battery will be subjected to various vibrations, especially considering the Indian roads. There will be too much vibrations on the battery. Now to test whether the high voltage battery will be able to sustain those vibrations or not, this test is conducted, wherein the tested device is firmly secured to the platform in such a manner to ensure that the vibrations are directly transmitted to the tested device. Then this battery is subjected to sinusoidal waveform between 7 Hz and 50 Hz and back to 7 Hz within 15 minutes. And this entire cycle is repeated 12 times for a total of 3 hours. And the acceptance criteria is that there should be no electrolyte leakage, rupture, fire, or explosion in the battery. Then another very important test is this thermal shock and cycling test, Now again, when you will be driving, through long distance routes, let's say from Delhi you are going to Ladakh, so there will be a thermal shock to the battery. It will be, in a if you go in summers, from Delhi will be 40 to 45 degrees Celsius, and there will be colder regions where there are temperatures below zero. So to test whether the battery is able to sustain such kind of thermal shocks, it is tested in the worst case, where you can see the temperatures are covered from 60 degrees Celsius and to minus 40 degrees Celsius. Again, in such tests, the acceptance criteria remains same, that there should be no electrolyte leakage, rupture, fire, or explosion. And then there is another test, which is a mechanical shock. Now, there can be scenarios where the electric vehicle has suffered an accident or a crash, but the case should not be that during the crash, the battery gets exploded. So to test such conditions, a mechanical shock is given to the battery, wherein the device is accelerated and decelerated to speeds specified in the regulation. The acceptance criteria remains the same. Then another test which simulates the crash situation is the mechanical integrity test, where the battery is crushed between a resistance and a crush plate with a force of more than 100 kilonewton. This again remains same.
Hi, Sahil. Can you hear me, sir?
Very most important test, I would say, in today's scenario is this fire resistance. The purpose is to verify the resistance of the battery against the exposure to fire from outside the vehicle, maybe fuel spill or situation within the vehicle. Now to test this, what happens is there is a pan that is filled with fuel, which is kept near the battery in such a way that it is directly touching the battery. I'll show in a diagram. So there are three phases. Phase A, which is the preheating. So what happens is there is a fire over here in the this is a gasoline test, so it will be done using gasoline, and this is your battery, which is the tested device. So in the preheating phase, the flame is kept 3 meters away from the battery. So this is 60 seconds of phase A. Then there is phase B, where this flame is directly under the battery, directly touching the battery. This is done for 70 seconds. And then there is phase C, in which a screen comes between the flame and the battery, which is the indirect exposure to the flame. So after these three phases, there is the end of the test, in which the fire is extinguished from the pan and taken back. The acceptance criteria for this test is that there should be no explosion during this test. Then another important test is the overcharge protection. The scenario should not be that we have installed the charger, and today when we have the fast chargers that charge the electric vehicle within half an hour. So, but if it is more than half an hour, let's say I went to a restaurant and outside I charged my vehicle, and I came back after 1.5 hours. The scenario should not be such that my battery is now dysfunctional. So for that, there is a separate overcharge protection circuit that comes into play, and the manufacturer has to ensure that. Then similarly, there is over discharge protection to simulate the scenarios wherein you have gone for a long trip, and after maybe 10 or 12 days you come and the battery is fully discharged and you're not able to charge it back. So for that, there is over discharge protection within the battery. Then there is over temperature protection, where the battery is repeatedly charged and discharged with a constant current to raise the temperature of the cells, and then it is evaluated further. So till now we talked about the Indian scenario and the Indian global Indian regulations and certification requirements. Now we will briefly cover the regulatory mechanism for Europe as well. So when if an Indian manufacturer wants to export their vehicles, as I told earlier, they have to comply with the European norms as well. Now within Europe there are two sets of legislations which are there, which are, one is the EU directives or the regulations. These are for the complete vehicle system and the for the whole vehicles. And then there are separate UN regulations, where there are regulations for testing of systems and components independently, but not the whole vehicle. Now, what is European type approval? It is very similar to the process is very similar to the Indian type approval, except for the fact that there are changes in the limits and the processes. Maybe in some parameters it is stricter, in some parameters it is lenient. What is about VC? I'll cover briefly. So Vehicle Certification Agency is an executive agency of the UK Department for Transport. So basically you can say this is the ARI of UK. And VCA is the designated UK type approval authority and technical service for most new on and off-road vehicles, ensuring that they meet minimum environmental safety standards. And also VCA is the designated body for the certification of packaging and transport of dangerous goods. So if you want to certify your vehicle and in UK or Europe as a whole, then VCA office is located in India. Where VCA sits within the Department of Transport. So in UK there is a Department for Transport and the Secretary of State and Parliamentary and the Secretary of State. So there is motoring services, which has shared services, future and SSC clients, agency sponsorship policy, and under all these there is VCA over here. Currently, VCA has offices around the world to meet the global demands of customers across a number of sectors. In India, we have 3 offices in Delhi, Pune, and Chennai. A brief about the journey of VCA India. It was launched in October 2006 in New Delhi, and the office is already there in Gurgaon, Pune, and Chennai. There are further plans to expand in different cities of India. Our simple aim is to provide Indian industry with testing and certification in India for export. Also to enable Indian automotive industry to compete on world stage and to improve road safety and environmental statistics in India. What type of services we offer? We offer the European Union whole vehicle type approval. We can certify your vehicle if you want to export that to Europe or UK or to other countries also. Then there's different system approvals for batteries or engines that we are doing. Different component approvals independently for seats, lighting, tires, seat belts, mirror, etc. Then we are also doing in India tractor OECD approvals and turnkey solution for the product market gap analysis. So thank you everyone. If there are any questions, so we can take up the questions now.
Hello. Thank you, sir, for the wonderful session. Now, I would like to ask all the attendees if they have any doubts or questions, you can ask.
Amol, Ritik, any questions from the attendees?
everyone. If anybody is having any question, please. There is one question about what is the approximate cost of certification. Hello.
I'm sorry, I was not able to hear you. Can you repeat, please?
Yeah, there is a question about what is the approximate cost of certification of a pure EV retrofitment in India.
So the certification cost, actually depends on different categories of vehicles. If I talk about M categories of vehicles, depending on your test requirements, it can go from a range of 25 lakh rupees to 50 lakh of rupees for the entire certification.
Navneet, I hope you got the answer. Anyone else having any questions? Okay, so since nobody is having any question, you can connect with us if you have any doubt related to this session. You can connect with us later on also. So I think it was indeed an excellent webinar on certification of automobiles, and I especially would like to thank and express my sincere appreciation to Mr. Sahil sir to give his expert thoughts and insightful words on this particular topic. And I'm sure that all our audience enriched by this session. I got the feedback in the chat box as well. So I hope everyone got the details about the regulations, policies, vision of Government of India, regulatory mechanism in India and Europe, various testing requirements and various tests that we conduct for the certification. So I would like to thank you, sir, for conducting such insightful webinar. And I would like to thank you all our attendees for joining with us today. You can stay tuned with us and you can visit our website at www.isieindia.com and stay connected with us. Thank you everyone.